Well, hello Year 7. Last lesson you learnt about the different processes that happen in rivers. You learnt about erosion, the wearing away of the river's bed and banks. You learnt about transportation, which is the movement of material in the river. And you learnt about deposition, which is the dropping of material. Today we're going to see how those processes actually make landforms. Landforms are things that we can see that have been shaped by those processes. So hopefully by the end of today's lesson, you'll be able to explain in good detail, using key terms, how those processes have shaped the landforms that we can see in and around rivers today. Now, bear in mind, as you go through the lesson, Mr. Aldred is going to be narrating. When he tells you to watch certain clips, you can find those clips in the announcements section on Teams. You can also find those clips on your calendar in the geography invite. If you have any problems, contact your teacher.
As usual, we're going to start today's lesson with a quick quiz. These questions actually refer back to the first lesson you did after half term. The answers to these will come in handy during this lesson. Please check your answers. Hopefully you might have got 5 out of 5. If you didn't, just correct the ones that you got wrong. We are now going to have a little look at how a river changes as it journeys to the sea. If you're feeling keen, I would like you to watch this video here. It's 10 minutes long and it shows David Attenborough in his younger days working his way down a river and showing how they change. It's good for this. It's only an optional video because it's 10 minutes long and will take you a little bit over the 45 minutes required for this lesson. Whether you watch it or not, I want you to think about these two questions. What changes can you see in the river and why do you think they occur? I'm not asking you to write anything down, but I just want you to think about it now. Pause the video and I'll explain it in a moment. So, the first thing I want you to notice is that this river, like all rivers, are split into an upper, a middle and a lower course. An upper, a middle and a lower course. Now, what tends to happen is the upper course, all rivers start off at a much higher point and go to a lower point. You'll never see a river flow uphill, they always go downhill. Now the upper course tends to be much steeper, and as it moves towards the lower course it becomes flatter. Now just to link it back to last lesson, in the upper course it's steeper and we get a lot more erosion taking place. So it's taking material from the upper course. In the middle course we tend to get a lot more transportation, moving material. And in the lower course we tend to get a lot of deposition, material being dumped down. So if you think about it, the river over the course of thousands to millions of years would work to flatten this landscape out. Now, one of the differences or changes that you might have seen is that the river becomes wider. So you might have said that it becomes steeper. It also becomes wider. This is because there is more discharge, there's more water flowing through the river. And this happens because water can join at any point during the river. It doesn't have to start at the source, it can join the river at any point, and so the river has a larger and larger discharge as it works its way down to the mouth, which is usually the ocean, but sometimes in lakes. Now, another key change that you might have noticed is the river starts off fairly straight and then begins to bend, or meander is a posh word, meander. This is because you've got in the upper course, you've got erosion will only really tend to take place in a vertical motion. It'll only dig down, and so the river doesn't change direction too much. As you get into the middle and lower course, the river will tend to flow faster and have a bit more energy, and has the ability to erode more laterally, sideways, and so you get these meanders in a river. Couple of changes that you can't see here, but you might have thought about, is that rivers become faster as they go downstream, and they also tend to carry more rocks and load with them as they go downstream. They also become deeper. This picture is of Dovedale in the Peak District. Hopefully some of you have been here. It's a wonderful place to go. Now I want you to look at these questions and have a think about it. So what shape is the valley? Which processes do you think have formed this valley? And what is your evidence? Pause it now and I'll explain in a moment. So this is the shape of the valley is V-shaped. If you can't see it, I'm going to try and draw it on here. So you can see this V. You've got a V shape to a river, and this is a common feature formed by rivers, V-shaped valleys. You might have heard of U-shaped valleys. They're formed by glaciers, but rivers form V-shaped valleys. Now, there's plenty of processes here that have caused this, and we've learnt these in previous lessons. Try and follow it step by step. So firstly, the river has dug down vertically. Okay, it's eroded its way down this landscape vertically. And it's done that in two major ways. Firstly, hydraulic action, the force of the water picking up material off the bed and transporting it down. And secondly, abrasion, rocks within the river smashing against the bed and banks and chipping off rock to then transport it downstream. Once it's dug down, this leaves the banks exposed to weathering. The key types of weathering that would have taken place here would be some freeze-fall weathering, as it is relatively high, so freeze-fall weathering on the rocks, and also some biological weathering. And one other one here, which should be also important, because it's limestone, there'll be some chemical weathering taking place as well. Now, this weakens the rock and breaks it down and leaves it, then makes it able for those chunks of rock that have fallen off to be moved by gravity down into the river, where they'll then be taken away. So that's caused this V shape to this landscape. Now, to answer the last question, what is the evidence? Well, some clear evidence that you can see here is this. This is what we call a scree slope. And there'll be one round about here behind these trees as well. What's happened is weathering has taken place on the rocks above, freeze-fall, biological, and it's chipped off material, and then that material is slowly working its way down, slowly via gravity to the river. Now these scree slopes are quite cool and interesting, but also people tend to get sort of caught up on them, and they can be quite dangerous. I did once see in this exact spot somebody getting mountain rescue for them because they got caught up on these scree slopes. You tend to lose your footing and you can quickly end up falling down. So one landform linked to V-shaped valleys is interlocking spurs. Now this is formed because basically a river will never move in a straight line unless it's man-made. It will generally curve around, what we call meander around. Now the side of the banks or the side of the valley which goes to the inside of meander is called a spur. Okay, so it's a spur. Now if you notice, these kind of crisscross over. If you look up a valley, they crisscross over a bit like a zip. And so this is why they're called interlocking spurs. So interlocking spurs. Now this picture to the left here is also of Dovedale. Now what you've got here is you've got the river which kind of moves its way down in that direction. This bit here is another river. But you've got, if I change my colour a little bit, you've got a spur there, a spur there, and a spur there, and a spur there, and a spur there, and potentially another one over there. This is a classic case of interlocking spurs. So all it is V-shaped valleys. You're just looking up the stream, and you'll see these interlocking spurs up the valley, and you see these interlocking spurs as the river meanders its way around. So this is the first key task for today. First thing I want you to do is write subheading, how do V-shaped valleys form? Then I want you to draw the 4 simple diagrams to the left, but in the correct order. I've purposely mixed them up. remember that firstly a river digs downwards via vertical erosion. This leaves the sides open to weathering. The weathering weakens the rock, and so therefore it's transported, it slips into the river, and then you're left with your V-shaped valley. Next to each of the diagrams, I want you to write one of the 4 statements to the right. These are also mixed up, and so you need to try and figure out which one goes with which. There's also a challenge question there. How does this lead to the formation of interlocking spurs? Please check your answers here. I'm going to go through it very briefly. So stage 1, the river's discharge is low in the upper course, so the river only has enough energy to erode downwards. This is called vertical erosion. Now vertical erosion is just the sort of the direction in which it's moving, so it can be included in hydraulic action and abrasion. Stage 2, the valley sides are slowly broken down through weathering. In the case of Dovedale, it'd be mostly freeze-thaw, chemical and biological weathering. Stage 3, the weathered material is transported via gravity and rainfall towards the river channel. This process steepens the valley sides. In stage 4, the steep-sided and narrow valley that is created is typical of upland rivers, that V-shaped valley. Now, to answer the question, how is this linked to interlocking spurs? Well, this V-shaped valley will be following the river. Now, the river won't go in a straight line, it will meander, it will change direction. So this means that you get these spurs crossing over like a zip, and these are the interlocking spurs. Moving on from that, what do you think Annie Edson Taylor is famous for? Have a little think, pause it, and I'll tell you in a moment. So, Annie Edson Taylor was an American school teacher who on her 63rd birthday, October 24, 1901, became the first person to survive a trip over Niagara Falls in a barrel. Why on earth she wanted to do this, I'm not sure. It sounds a little bit like a death wish to me. I've been lucky enough to visit this place, and I don't see how anybody could survive falling down that waterfall. But the reason why I've just told you this is that we're going to look at waterfalls as our next river landform. So before we get started, you really must watch this video. It is very good at explaining the formation of waterfalls. Now, I'll explain it briefly myself, and then I'll explain the task that I want you to do. So waterfalls generally, mostly occur when there's 2 different types of rock, where the river flows over 2 different types of rock. So harder rock on top and softer rock at the bottom underneath. The softer rock gets eroded much more quickly than the harder rock can. So you tend to get this step in the river form. Now this increases the force of the water, and so you get more hydraulic action taking place, which only works to dig away at the softer rock even faster. As this softer rock is eroded underneath the hard rock, it creates a notch an overhang where the hard rock is hanging over the waterfall. Now this is going to get undermined more and more as the softer rock underneath is dug away at or eroded away at, and so eventually that notch will fall into the river. All the time, any rocks in this river will be used to add further abrasion and abrasion, digging away at this softer rock. This basically means that this waterfall shows that over thousands and millions of years, it will erode backwards, and so the waterfall is constantly moving backwards very, very slowly. And this creates a certain type of valley called a gorge. It's steep-sided, often very deep water, and it's a gorge that waterfalls leave behind them, or in front of them even. What I want you to do now is this second key task, and the last task for today. I would like you to explain using diagrams in your own words the 4 key stages of formation of waterfall. So there's 6 stages to the right there. I want you to try and summarize this in 4 stages, with explanations next to each one. You might do this in 4 straightforward pictures with explanations underneath. There's also a little picture, here of another way of doing it. So you could do almost like a little comic strip type thing. This is the thing that I want you to take a picture of and send to your teacher via Show My Homework or via email. Okay, well done for completing today.